Okay, so I think I know what's wrong with switch number 1. Now before I do it, let me go in here and show you. Okay, so let's go into switch number 1, S1. Okay, right here, if you can see this, when I type in S1, it said connection refused by remote host. When I type in S1 or R1, the terminal server says, okay, I need to establish a new connection to S1, which is on octal cable 1, or R1, which is on octal cable number 3. But here's the thing. If the terminal server looks around and says, uh-oh, there's already an electrical connection on that octal cable. That octal cable is already being used to host a console session. Then I'll get this message. This is basically saying you can't create a new session to S1 because S1 already has a session to it. So that my next logical question would be then, okay, well, which session is it? And I can just do the show session command. It says right here, okay, connection number 1 is going to S1. I don't know if you can see that very well. I think I can make that a little bit bigger. Right there, connection number 1 is going to S1. So now all I have to press is the number 1 and then enter, and that gets me into that existing connection. All right. So why is Fast Ethernet 0/1 not lighting up? Why is it not giving me pretty colors here? Show IP interface brief. And if you look at my CCNA videos, you'll learn a lot more about that command. All right, so this says Fast Ethernet 01 is down, and yet I absolutely do have a cable connecting to it. Ah, I think I know what the problem is. The setup here on my desk is my laptop is connected into a docking station. When I took this cable right here, I connected it directly into the RJ45 jack of the laptop itself. My suspicion is that when it's in a docking station, it probably deactivates that because the docking station itself has an RJ45 jack. So I bet you if I plug this into the docking station's RJ45 jack, it'll say, oh, yes, there it is. If I can just find that connection. Let's see here. And where is it? There it is. And do we have success? Now I see the lights going on the switch. So that was it. It wasn't a cable problem. It wasn't a problem with the switch port. It's simply a fact that my laptop was connected to a docking station. All right. All useful troubleshooting tips. All right, so that's that. So let's go ahead and continue my wiring here. Let's see here. Let me get back to my whiteboard. So now I want to connect 024 on switch 1 to 024 on switch 2. And for that, I'm going to want to use this red crossover cable. Okay, just did that, and sure enough, the lights are starting to come on right now. And you can't see what I'm seeing, but what happens is initially the lights go on, they're sort of an amber or a brownish color, and they stay that for a while, and then they turn green. So green means the switch port is wide open for sending and receiving traffic. Amber or brown that happens first means it's actually going through something called spanning tree. And if you take my CCNA videos, you'll learn what spanning tree is. That's something that's taught at the ICND 2 level. But spanning tree has to do some stuff first before it opens up the port and the light turns green so it can actually be used. Okay, so I did the switch 1 to switch 2 connection. Now let's just finish this off with the switch 2 to the router 1. That's going to be a straight through. Okay, so on switch 2, I'm going to take 0/1 right there, and I'm going to connect it to 0/1 of router 1. There we go. Okay, and now to complete my, so that's building 1. Building 1's done now. Now to complete my cable, I'm going to do the stuff here in red. So I need to connect my WAN cable now, and for my WAN cable, that's where I'm going to use this funny looking guy. Let me make this a little bit bigger here so you can see it. So this is a serial cable, and you can see it's got a special connection on the end of it, and I think I have a bigger picture of it for you. There we go. So the one I have is significantly shorter than that, but it looks almost identical to that. The ends of it look like this. I honestly don't, I think this is called a DB60 connector because it has something like 60 pins, but I don't quote me on that. But when it comes to serial cables, there's all sorts of different connectors. Basically, the type you get is dependent on what are you connecting it to, right? You need to connect, whatever you connect it to has to support that type of connection. And I don't know if you can really read it on here, but one end of the cable, this end right here, it's written as DCE. And this end right here is written as DTE. And that's actually going to be important when it comes to the configuration side. So I can plug either end of this into my routers, but I will have to know which side is DCE, and I'll tell you why in just a second. So let's go ahead and go back to my diagram here, and I'll plug router 1 to router 2. So looking at my picture, where is that? Right here. So here's router 1 and router 2, and I'm going to use that special cable to connect from here to here. So let me go ahead and do that. Okay, I've just connected router 1's port. Now I'm going to connect router 2. Now serial connections are becoming a thing of the past. These days, Ethernet, hold on a second. These days, Ethernet is by far the most predominant technology. So serial cables are becoming less and less popular. But I have connected those two together. Now, it says slot 1, but I don't necessarily know, like these over here, these fast Ethernets clearly said, oh, that's fast Ethernet 0/1 or fast Ethernet 0/0. But I don't know if I'm going to configure this interface, and if I'm going to label my diagram with the interface, I need to know exactly what interface number that is. Is it just serial 1? Is it serial 1/something? So in order to do that, I'm going to get into the router. Let's go to show session. Do I already have a connection to the router? Yes, connection number 3. And right now it's presenting me with what's called the initial configuration dialog, because I wiped out the configuration of this router before this class to set it back to factory defaults. And this is the dialog message that you get when you power up a router or switch and it has no configuration. So I do not want to go into the initial configuration dialog because that'll take me a million years to do just like 3 simple things. Instead, I say no. I'll give it a chance here to do whatever it's going to do. There we go. And I can use that same command I showed you before, show IP interface brief. In this particular case, now I know what my serial is, serial 0/1/0. So I'm going to label my diagram with that. So this will be 0/1/0, 0/1/0. And when I connected it in, router 1 has the end of the cable that was labeled as DTE. Router 2 is labeled as DCE. Why do I care? Why is that important? The reason that's important is because, remember, what's going on a cabling? We have electrical signaling. So we have different electrical pulses going off that cable. And now I am not an electrical engineer, but let me sort of describe to you the way it was. I read something a long time ago that sort of made an image in my head. So think about you have 2 batteries in your hand, a little 9-volt battery and a car, an automotive battery, okay? You put the 9-volt battery to your tongue, zzz, right? Gives you a little zap, right? You put that car battery to your tongue and it burns the hair off of your head. Both have electrical energy, but the quantity, that jolt that you got was definitely different because the voltage is different. Someone described the concepts of amps and volts to me. Back a long time ago, I was sort of like wondering, what does that mean? You know, amps and volts, because when it comes to electricity, you'll see that, 120 volt outlet, 3 amps. What does that mean? Here's the way someone described it. They said, think of it about this way. Electricity running through a cable, what is it really happening? It's electrons running through that cable, right? It's the electrons, the electrical, the negative charge of an atom, electrons going through the copper in that cable. That is your electricity. So they said, imagine that instead of electricity, you had a hose with water. And each electron is corresponding to a drop of water in that hose, okay? So if you had the water turned on, you put your hand up against the end of that hose, you could measure how much pressure was coming out of that hose. So that would be like volts. The greater the volts, the greater the pressure. So like if I turn up the hose, I've got more water going through and it's putting more pressure against my hand. So if I have a battery that's a 9-volt battery and a 100-volt battery, the 9-volt battery, the electrons it's putting against my tongue are very weak in pressure. The 100-volt battery, much stronger in pressure, okay? This will make sense here in just a second, trust me. And then when it comes to amps, someone described it this way. They said, using that same concept of water in a hose, if I take a look at, like, say, 1 foot of that hose, I could measure how many water droplets are passing through that 1 foot in like a second. If I just have the water turned on just as a trickle, the water droplets, there's not that many going through that 1 foot section of hose in that period of time. If I turn the water up, then there's more going through there in that period of time. That's like amps. In electricity, if I take amps, the higher the amps means the more electrons are being pushed through faster. They're being pushed through more quickly through there. Now, like I said, I'm not an electrical engineer, but I've sort of used this analogy to visualize things in the past. And so how that relates to this is that all of these protocols like Ethernet, they say, we're going to break data down into electrical energy, and that electrical energy is simply going to be represented as ones and zeros. What does that mean? That means if I'm sending the letter A across a wire, it's going to break that A down into, like, say, 11000, and then it's going to use electrical energy to represent those ones and those zeros. So it might say, okay, here's what I'm going to do. Ethernet might have a rule that says, well, to represent a 1, I'm going to raise the voltage to a certain level, a certain pressure, and I'm going to hold it for a certain amount of time and then let it go. And when I'm transmitting a 0, I'm going to raise the voltage maybe just to a different level and hold it for maybe a different amount of time and then let it go. So that's how electrical energy can be used to represent ones and zeros. It's a variation of like the voltage, how much voltage you use and how long you hold it before you let it go. So when a NIC card, like on my laptop, sees voltage coming in, it says, okay, number 1, is that voltage coming in what Ethernet would define as a 1 or a 0? If the voltage is like this, it says, okay, that's not within the scope of a 1 or a 0. That's just electrical garbage. But let's say the voltage comes in, it's like this much. It says, okay, well, according to the rules of Ethernet, that much voltage is a 1. And so it would look at that, it sees it go away, and it says, okay, that was a 1. Now voltage comes in like this. Oh, according to Ethernet, that much voltage is a 0. And then that goes away. All right. So for that to happen, the network interface card on my laptop or on a router or on a switch has to be monitoring that voltage as it comes in. Because there's going to be periods of time when the voltage comes in, and there's going to be periods of time when it's let go and there's nothing. It's just idle. There's nothing on that wire. So it's sort of like, you are waiting for a letter to be delivered, and yet there's somebody in your neighborhood that is stealing your mail. Okay? So you're going to be looking out your window periodically to see if the post office, if the mailman or mailwoman delivers your letter. And if you're looking at just the right time, you'll see that letter delivered so you can run out there and grab it. But if you've turned away from your window and you're in your kitchen, the mailman could come, deliver the letter, the mailman could leave, the thief could come, steal that letter, and now when you look out there, the mailman's not there, and if you check your post office box, there's nothing in it. Same thing with a NIC card. A NIC card, like billions of times per second, checks the wire and says, okay, is there voltage coming in right now? No, there's not. Okay, I'll stop. Let me check. Is there voltage coming in right now? No, there's not. I'll stop. So it's checking the wire. It's scanning the wire for these pulses of electrical energy. So what could happen is there something coming in? No, there's not. The wire's empty. It looks away, and in that microsecond or nanosecond it's looking away, the voltage comes in as a 1 or a 0, drops, and then it looks, and it missed it. So in all these networking protocols, we have to have something built in called clocking. Clocking says, when I put the voltage on the wire as a 1 or a 0, I want to make sure I do it in sync with when you are looking at the wire so that you can see that voltage when it comes in. Now, Ethernet, because Ethernet is a LAN protocol, it says, look, devices are really close to each other. So their clocking will be, if not identical, it'll be really close. So Ethernet has a lot of built-in protocols to make sure that voltage levels aren't missed, that 1s and 0s aren't missed, or if they are, only a few of them at the front end are missed that aren't really that critical anyway. But when we're talking about a WAN connection, like this red connection here, where the devices could be miles apart from each other, clocking becomes very important. It becomes very important that when this guy puts a 1 or 0 on the wire, when it goes 5 or 6 or 10 miles to this guy, he is looking at the wire at the exact time when that pulse comes in, so he can read it and he can understand it. So for that reason, on this type of a connection, on a serial connection, one side provides a heartbeat. One side provides this constant electrical heartbeat, pooh, 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 and the other side listens to that and locks onto it. And now that they're synchronized with their clocking, they can both transmit, they can both receive, and they don't have to worry about missing the 1s and 0s. That's where DCE and DTE come into play. In a lab like this, where I'm connecting 2 routers, right here, 2 routers back to back with a serial cable. This is my connection. One of these interfaces is going to have to provide this clocking, this heartbeat, because it's a serial interface. It's expecting to connect to something really, really far away. The other side is going to receive the clocking. The DCE side is the one that provides the clocking. There's actually going to be a command I'm going to type in called the clock rate command on the DCE side. That's why I said it was important for me to know which end of the cable was labeled DCE versus DTE. Now you might be wondering, well, what if I get into a network environment where I'm not physically in front of the routers? I know they're connected via serial, but I don't know which side is DCE or DTE. I don't know which side needs the clocking command because I can't see the cable. Well, there's a command you can issue to actually give you that information. Let me bring this up. So that command is show controllers, and then you type in your serial interface. A lot of gobbledygook in here, but what you're looking for, and I'll zoom in on it here to make it a little bit bigger, is you're looking for this. Right here, about the 3rd line down, DTE. So I know that this router, I am not going to need the clock command because that's the DTE side. And that's router number 1. So it must be router number 2 that requires that. Let's go ahead and look on router number 2. All right, so show controller serial 010. And here we see DCE. So this side's going to need the clock. So I'm just going to go into that interface right now, interface serial 010, and the command, I'll zoom in on it here so you can see it. clock rate. And if I use a question mark, you can see there's lots of different rates. My experience has been that if I select some of these upper rates here, the interface flaps. It goes like down, up, down, up. I'm not sure why. So I tried choosing something towards the higher end, but not at the very high numbers. I'm not sure why it doesn't like the high numbers. So I'm going to choose 800,000. Now here's another way you could tell. What if I had typed that command in the wrong router? What if I had typed it in on the side that was DTE? Would the router have blown up and spitting shrapnel all over my face? No, it wouldn't. So let's go into router 1. Interface serial 010. If I try doing the command here, watch what happens. It says, error. Only applies to DCE interfaces, so it didn't take the command. All right, so I have now got a lot of my configuration done, my cabling, I should say. Now I just need to finish this off. Router 2 to switch 3. So let's just do this here. Let's say that on this side, I'll have fast Ethernet 0/1 going to 0/1 here. And here I will have 0/24 going to 0/1 here. All right, so let me find a couple more straight through cables. And there's a question, who decides which side should be DCE or DTE? Some authority? It's just whoever made the cable. The cable itself, one end was labeled as DCE, the other was labeled as DTE, and the manufacturer of the cable just made it that way. Like I said, I'm not an electrical engineer, so I don't know if there's actually a difference in the pinout or anything like that. All right, so let's see here. I want router 2, 0/1. That's this guy right here. And I want him to connecting to 0/1 of switch 3. All right, I did that. And lastly, one more straight through cable. So we're running out of short ones here, so I'm going to use some of these longer ones. And that's going to be the last interface on the switch, going to 0/1 on the router.